Namaste, dear students. In our last class, we had discussed about the different types of the ores of different metals like silver, iron, copper, aluminum and gold. And the molecular formulas of these ores also we had discussed. But in our today's class, we are discussing about the different methodologies, that is different processes to be followed to extract the pure metals from their impurities. As we have already discussed, the impure form of the metals is called what? The ore. So, can we obtain or can we extract these metals in pure form through sieving as well as through sedimentation as well as evaporation? Do you think these processes are suitable for the extraction of the metals? Obviously not. So, we need to follow different other metallurgical processes. We will be discussing on the different types of the metallurgical processes. So, obviously there will be different processes for the different types of the ores. For example, before taking it out into the industries for the extraction, we need to we need to taken out what? The impure form of the metals, that is ore from the mines. So, the process of incaving out the mines or the minerals from the ore, from the mines, that is called the mining process. So, in mining you can see the figure that what the person is doing there. Obviously, he is digging out the that minerals from the mines. So, this process is called what? Okay, that is mining. So, it is one of the first step, one of the step. This is not the first step, but this is one of the steps of the metallurgy, through which we can take out the petroleums as well as gold as well as other different ores of the minerals. The next one, we need to follow different types of the metallurgical processes, which can be shown in the diagrammatic form here. So, there will be different chambers for the extraction of the metals. So, it is not necessary for us in this grade, but what is the process, what is that diagrammatic sketch to represent the metallurgy, it has been shown here. In fact, the first step after taking out the minerals or the ores into the industry is, first of all, we need to grind, because big lumps of the ores are taken out. Then to convert that big lumps into the powder form, we need to grind it by the grinder. The next step is we need to concentrate, because there will be different types of impurities. Based on the presence of the impurities in the ores, we need to follow different types of the concentrations. The next one is oxidation. The metals will be oxidized so that it will turn into the metallic oxide, through which we can easily extract through the chemical process. Okay. So, next one is reduction. After oxidation, we need to do the reduction. Then in detail, we will be discussing about these processes in next slides. Next process is, finally, after the reduction, we need to refine it to obtain the pure metals. So, these are the key steps to be followed to extract the metals. Okay, so we are discussing about these processes in detail now onwards. So, the first step is, you can see here, that is grinding. As I have just told you that the grinding is a process in which we need to convert the big lumps of the ores into their powder form. So, such type of grinders are used in the industries. You can see in the screen that this is the first step, and the big lumps are being converted into the powder form. So, after the grinding, we can find the ores into such forms. You can see here, this is the powder form. The big lumps were being fed through this wafer here, so that it has this grinder has turned these big lumps into the powder. This is the powder form. So it has been shown here in this powder form. So this is the grinding. This is the first step of the metallurgy also. So the next step is concentration. So as I have just told you that according to the presence of impurities, we need to follow the different steps, different processes for the concentration. The first one is magnetic separation. So if you want to separate the magnetic impurities or magnetic substances through the non-magnetic, we need to follow this magnetic separation process. So when this is the magnetic roller, then the impurities or the powder form of the ore has been fed through this hopper, then it has gone through here. Then non-magnetic substances are just going away from the magnetic roller, but the magnetic powder form has been just reaching towards going towards the magnet, because the magnetic substances are being pulled towards the magnet. So that due to the attraction force applied by this magnetic roller, the powder has been just going towards this side, so that non-magnetic particles have been collected towards this side, as well as magnetic have been collected towards this side. So this is the that one of the steps for the concentration. You can we can just do here. You can see in that video also that impure form of that powder form has been fed through this here, so that the magnetic substances have been gone towards this side, but non-magnetic substances has gone towards this side. Next one, on the basis of the presence of the impurities like that the non-metals as well as the dust particles, these dust particles are being just removed by this that process, in which the powder form of the impurity has been collected here in this vessel, and the that air has been blown through this the inlet, so that when air blows here, then obviously there will be that froth will coming upward. If the impurities are that lighter than the metal, obviously they will come upward, then a froth will be skimmed out. Froth which are being present over this here, they will be skimmed out. Then the heavy particles will be collected at the bottom of the container. So you can just see here in this video also, air has been just violently just passed through this inlet, then it has gone towards this vessel, in which the impurities have been collected here, so that the after that reaching the pressure of the air, then froth will coming out upward, then it will be skimmed out, so that the heavy particles or heavy metals will be at the bottom of the container, then it can easily be taken out for the further process. So next next metallurgical process of the concentration is gravity separation. In this gravity separation, you can see in into the crusher that industries also, we can see such type of that mechanism here, in which the crushed ore has been fed through the through the hopper here, then it will going downward. After this, then the heavy particles will be just going downward, and the lighter particle will be just separated through this corrugated beads. The next step of the metallurgical process is, or we are just summarizing the concentration process. It is a method to remove the impurities like sand, mud, stone from their ores. The next feature of the concentration process is it is used to that high of the percentage of the metal to be obtained. Next one is it has different methods based on the nature of the impurities present in the ore. That means sometimes we use magnetic separation, sometimes we use froth flotation, as well as sometimes we may use the gravity separation according to the nature of the impurity present over the that ore. Next, gravity separation is done if density of metal and density of impurities is different. If the density of the metal as well as the ores or impurity are similar, we cannot that follow this gravity separation. If they do have got the different that densities, obviously they can easily be that separated in different vessels. So it is used for the that impurities as well as the metals, they do have got the different densities. Next one is magnetic separation. We have already discussed when the impurities as well as the metals, sometimes the metal can be magnetic, but sometimes the impurities may be that magnetic. So in such condition we can use magnetic separation also. And at last froth flotation is used for the hydrophobic as well as the hydrophilic. That means if the impurities can be dissolved in water, that is called what? Hydrophilic. Philic means loving, hydro means water. When the impurities are that soluble in the water, okay, in such case we can use this froth flotation. So these are all about the concentration. Next we are talking about the next step, that is oxidation. In fact, what is oxidation? I think in your in grade 9 also you have already used the term oxidation, in which you had discussed, you had learnt that the addition of oxygen in any metals or any substances or any other elements, that is called the oxidation. So in this metallurgical process also oxidation is important, because when we convert metals into metallic oxides to obtain the metal, so this process is called the oxidation. In oxidation, the metals, if you take the hematite, then you can convert iron into iron oxide. If you take aluminum, aluminum can be converted into aluminum oxide. So this is the conversion of what? Metal into the metallic oxide. So in oxidation we need to we do have two steps. They are roasting as well as the calcination. So we need to discuss about what is roasting, in which condition we need to use the roasting process, as well as in which condition we need to follow, we need to obey the calcination. So according to the impurities present in the ores, we need to follow either roasting or the calcination. So the terms will be defined first, then at which condition roasting is followed, as well as at which condition calcination is followed, we will be discussing in detail in the next slide. Roasting is the first step of oxidation. In oxidation we always use that conversion of metal into metallic oxide. So metallic oxides can be found by in presence of air or in absence of air. So out of these two, the first one, this roasting, is the process in which we use excess of air to convert metal into metallic sulfide into metallic oxides. So you can see the example that when zinc sulfide is treated with oxygen, then obviously it will give zinc oxide as well as sulfur dioxide. Reaction is not necessary for us in this grade, but how it is converted into metallic oxides, we need to know this. So for this I have given an example, that is zinc sulfide has been converted to zinc oxide in presence of air. But if I give one example for you, that is iron sulfide, then when iron sulfide is oxidized or that roasted with in presence of air, then what does it give? Okay, it gives iron oxide. So this is the conversion of iron sulfide into iron oxide. So this is one of the processes of the oxidation. That is roasting. The next one is the calcination. In contrast with the roasting, it is of quite different, where in roasting we had used excess of air, but in calcination we need not to use the air, that means oxygen. So in the absence of oxygen also, the metallic carbonates as well as metallic that oxides like calcium oxides, they can be converted into their respective oxides. So calcium carbonate, when calcium carbonate is heated, obviously it will give calcium oxide, CaO, as well as carbon dioxide. So this is one of the conversion of what? The conversion of calcium. Calcium is the metal, as well as when it turns into oxide, that is calcium oxide. This is conversion of metal, that is calcium metal, into calcium oxide, metallic oxide. So but we hadn't used, we need not to use the oxygen here. So this is called the calcination. So this is also one of the way of the oxidation of the that metallic that different form of the metals, that is the ores. After oxidation, obviously we need to go into the reverse process, that is called reduction. What is the that is reverse form of the oxidation? Okay, as we have discussed, the conversion of metal into metallic oxide is called oxidation, but here we need to know this, that the reduction is the just reverse process. We need to remove the oxygen from here so that it turns into the metal. Okay, so we'll be discussing on the same thing here, the removal of the oxygen from the metallic oxide, because we have obtained the metallic oxide from the oxidation process. So after obtaining the metallic oxides, we need to follow the next step, that is reduction, in which the oxygen should be removed so that it turns into the respective metal. So by using carbon monoxide as well as hydrogen as well as other that ways, we can convert the metallic oxide into the respective metals. For example, by taking the copper oxide, we can convert into the copper. By taking the lead oxide, we can convert into the lead. As well as by taking the iron oxide, after the oxidation, we need to convert it into the iron. In these processes, obviously you can know that the metallic oxides have been converted into the metals by the removal of oxygen. So it is called the reduction process. Next one is by using carbon for zinc oxide. This is another way to convert metallic oxide into metal. Next one is by using heat for silver oxide and mercury, because only the heat will be sufficient to convert the metallic oxide into the respective metal, because they are quite unstable in nature. Okay, so they are quite reactive in nature. So the simple or gentle heating will be enough to convert the respective metallic oxide into the metal like silver oxide as well as the mercuries. Next one is by electrolysis method also, the metallic oxides like sodium oxide can be converted into the respective metal like potassium oxide, calcium oxide and so on. Because when in the electrolysis process, these oxides are unstable in nature, in electrolysis only, so they are unstable, so they can easily be converted into the respective metals. So these are all about the reduction. But while taking these, okay, these are the chemical processes, but when these metallic oxides are taken into the industries, then we need to follow one major method, that is called smelting. Smelting is a process of conversion, or that is removal of the oxygen from the metallic oxide into the respective metal. But while converting the metallic oxides into the respective metals, the metal will be melted, but other volatile impurities or the oxygens can be evaporated out, or they will be removed out in the form of the gas. So this is all about the smelting process. The smelting process is done at high temperature, and in high temperature metal will be melted, and you can see here this is the process of smelting. The impure metal will be fed into or will be kept inside this kiln, and heat will be supplied here. Then impure form will be just taken out here, as well as the molten metal will be taken out through the outlet present at the bottom, in which the gaseous impurities will be skipped out through this, okay, that outlet chamber. Okay, so this is all about the smelting process. It is also one of the that reduction process during the metallurgical process of the extraction of metal from the ores. You can see here inside this kiln, the heat or the molten mass or this is the internal structure of this smelting process or this kiln. Here you can easily see here that the temperature inside of this kiln is quite that high, so that all of that things which are kept inside, they are in very high hot condition here, so that due to the heat presence okay, inside it, the molten metal will be converted into the molten form, that is will be come downward. This is through the top, then it goes downward like here, then it will be taken out here. This is all about the smelting process. Okay. Next we will be talking about this is the last step for the preparation, for the extraction of the metal. Because in previous processes, we at first we just taken out the ores from the mine, then the mine, after taking it out, we grinded it, and it had turned into the powder form. The powder form of the metal was being concentrated by 3 ways, that is magnetic separation, Froth flotation, as well as gravity separation. After the work obtaining after the concentration was fed into what? The oxidation. Oxidation was done by 2 ways. They are roasting as well as the calcination. The product which is obtained from the oxidation was taken it out, and it has been smelted right now. That is, reduction was done. After reduction, the metal is mostly that most of the that impurities have already been just what? Thrown out or separated out. At last, this is the refining process through which the pure metal will be obtained. Refining process will be done by 2 ways. First one is distillation. Distillation process is done. It is quite familiar, that process for you, because in your earlier classes also you had discussed about the distillation. Next process is electro refining, in which it is based on the that electrolysis, because you all know about the electrolysis. Electrolysis is the process in which the metals are separated by the presence of electricity, in presence of electrolyte also. So the figure you can see here, if you want to collect the pure metal, you have to that join the electricity or through the anode. The impure metal will be connected towards the anode, because anode always eroded, and the metallic particles which are eroded from the anode will be deposited at the cathode. If you want to suppose if you are going to purify the silver from the impure form of the silver, you have to put or keep into the anode. Anode is the electrode in which the this is the positive terminal of the positive terminal of the electric that circuit, in which the positive terminal of the battery is connected. So in this electro refining, this is the very after that electro refining, you can obtain 99.99% purity of the metals. Next one is as I have already discussed about the distillation. Distillation is the process in which you can just evaporate the content by keeping in distillation flask, and all the impurities will be just thrown out as well as escaped out, and the purity or the pure metal will be remain at the bottom of the container. So these are all about the different metallurgical processes for the extraction of the pure metal. Now we are discussing about some questions related to the discussions that we have made today. The first question related to this is, which of the following is the correct about mining? We all know about the mining, because at the first part of our today's class I had discussed about what is the process of mining. So out of these 4 figures you can see here, to which process does this figure relate? Yes, this is about smelting, which is the reduction process, as well as this is about the froth flotation, this is concentration, as well as this third one is electro refining. So this is the refining process, as well as this one is the the mining. So the correct answer is this D. The next question related to this is, which of the following is correct about obtaining metal from ores? As we have discussed, the first step was mining. After this we had done the grinding. After grinding, the powder form is taken for the concentration. Next one is Good, oxidation. The next one is, after oxidation we have to do reduction. Then final step is refining. So which of the out of these 4 options, which one is the correct option? Obviously, okay, this B. Second option is the what correct answer for the question. Next question is, choose the correct option from the following. So I have given 2 columns here. The first column has given the methods of separation of the metal, and second one consists the process to be followed to extract such metals. And you have to establish the relationship between, or correct relationship between, column A and column B. That means method as well as the process or the conditions. So we need to go into the first option, that is gravity separation. One represents gravity separation, and does it have the relationship with the distillation? Does the gravity separation mean the distillation? No. So you need to, if you have found an incorrect relationship between these two, you need not to try to establish the relationship with others. You need to move into the another option. So second option has, one has a relation with the B. That means gravity separation is the process in which the density of metal or impurity is different. Yes, this is correct. But if one relationship is correct, it may not be it may not be that certainty that other relationships are also correct. So we need to analyze in all. So second one, 2C, roasting means obtaining metallic oxides in presence of air, oxygen or the air. Okay, this is also the correct. And you have to go into the another relationship, 3D, that means calcination. Calcination means obtaining metallic oxides in absence of oxygen. Just in calcination, we have to heat the carbonate of the metals and they will turn into the metallic oxides. So the third relationship is also the correct. If 3 relationships are correct, obviously fourth one is automatically correct. So that means smelting means distillation. In smelting, the metal reduced metal or oxidized metals are fed into the wafer, then they will melt and the molten mass or molten metals will be taken out and other the impurities will be distilled out. So this is all about the relationship with the smelting and distillation. So the option number B is the correct answer of the of this question. Next question related to the discussions or in related to the today's class is, write general methods of purification of metals. So in general methods we have discussed that mining as well as grinding. What is the next one? Okay. After that you have to do the concentration. After concentration, what is the next step? Good. We have to oxidize, that is oxidation. After oxidation we have to do the next one. What is that? Good, that is reduction. What is the final step of the purification of the metal? Refining. Okay, in refining also we have 2 methods, electro-refining as well as the distillation. Another question is, write the suitable method to convert the following to separate magnetic metals from their ores. We have to do what? Magnetic separation. Okay, you have to say the answer of the second question. To convert zinc sulfide into zinc oxide. Which method is used for this? Okay, can anybody say? Good, we have to do what? Oxidation. To separate oxygen from metallic oxide. In which process do we do this? In reduction. Good, you have said the correct answer. The fourth question related to this is, to purify metals obtained from the reduction by distillation. That means it is the refining process. Next question related to this is, we have to differentiate between roasting as well as the calcination. We had discussed about these 2 terms enough, I think. Based on the discussions that we have made in our today's class, you can write yourself. Oxidation as well as reduction also, and concentration and smelting. You have to write differences as much as possible, but in examinations there may be the particular number of the differences to be written. Okay. Next question related to this is, you have to study a figure which is given here. in which it has been labeled as A, B, C, D and E. So, you have to write the names of A, B, C, D and E. I am just giving the names. A is anode, because as I have already told you that the positive terminal of the electrode at which the positive terminal of the battery is connected, that is called anode. A is anode. And B, in B there is the negative terminal of the battery, so that is called cathode. C is in what, electrolyte. And D is a voltmeter, because voltmeter is a device in which we use to do the electrolysis. And E are the impurities present on the what, electrorefining process. So, this is all about the answer solution of the questions given in the screen. Okay, at last I have brought a project work for you. You have to do this project work, and you have to present at your class, and after this you have to submit to your teacher. So, project work is you have to prepare a summary chart of various methods that you have discussed to obtain the pure metals from their ores, and you have to present it in your classroom, and finally you have to submit. Take a chart paper, and just by taking the different colored pens, you have to make the diagrammatic sketch of the processes to be followed to extract the metal, and you have to present at your classroom, and finally you have to submit. Each helps you to memorize all the processes at once in a single glance. So, I think you all have enjoyed in today's class. So, we discussed about all that processes to be followed to purify the impure metals into the pure form. So, we will be meeting in the next class. So, for today I want to conclude my today's class. Thank you.